So today we are going to start a new topic called calorimetry. So the word calorie, there is a history of this word calorie. So earlier the heat was assumed to be some moving liquid. So they thought it's some sort of fluid which goes from one body to other body, and they called it calorie. Now the absolute measurement of heat is not possible. We cannot understand how much heat is stored in a body. So what we can really measure is what goes from one body to other body, or you can say in a way, what flows, what transit, what is exchange could be measured, but not the actual amount of any body. So this is also one form of energy, and this energy differs from other energy in a way it is transacted. So we say that heat is a form of energy which transact between two bodies by virtue of difference of temperature. So for heat to transit, the difference of temperature is mandatory or compulsory. So let's start with the heat first. So it is of course a form of energy, but it differs in the process. Okay. So it is form of energy which flows between bodies due to difference of temperature. So work is also energy, heat is also energy, but the reason of work is force and its displacement, right? The point of application, heat is form of energy, but it is not similar to work. It is the energy which only measure in the transient form. So we have to mention this also separately. So it is a form of energy which flows between bodies due to difference of temperature. It can only be measured in transient form. Absolute heat content of body cannot be measured, but the transaction can be measured on. Okay. So these are basic fact about the heat. Om, are you there? So there are some basic definitions.
Yes, sir.
Back. So we are doing calorimetry actually.
इधर ही था सर.
अच्छा पूछ तो रहा था मैं where are you? Okay, anyway. Now there are some definitions which we need to know in this chapter, which are very fundamental definitions. So first is called heat capacity. The symbol we use is capital C, and it's very simple. So if you have any body, now you do not know the mass of this body, right? So mass is unknown. So the amount is unknown, right? Now whatever energy you give, so we are talking about the heat energy given. So we represent by the symbol capital Q. If some energy is given as heat, it will change the temperature, not necessarily, but let's say it will change the temperature by some value called delta theta, or you can use symbol delta T. Now in this chapter, capital T we use for temperature and small t we use for time. So if I have to write the rate of change of temperature, I'll write dt by dt. Okay, so I think you should not be confused, because from context we'll come to know what it really means, right? Now the question is, for a given amount of substance which is unknown to you, not known to you, how much energy we need to raise the temperature by 1 degree Celsius or 1 Kelvin? Okay. How much, whatever we need for 1 degree or 1 uh, Kelvin, that is called the heat capacity of that unknown amount of substance. Which means if I know the heat capacity of substance, then amount is not required, because we know that 1 degree requires this much energy, so 2 degree will require double of that, and 3 will require triple of that. So a change of delta T will require how much?
डेल्टा टी होता है.
Delta T times C, right?
हाँ वही. Yes, sir.
So the heat capacity by definition is amount of heat required to raise the temperature by 1 degree Celsius. Now, if I use delta T in degrees Celsius or Kelvin, the C will have the unit of joule per degree Celsius or joule per Kelvin. So the unit will be, now this we use by default SI unit. But can we define in degree Fahrenheit? No, we can define. That's not an issue. We can define in joule per degree Fahrenheit, but the definition of C in Fahrenheit is going to give you lesser value of C than, because to change the temperature by 1 Fahrenheit, we need less energy, na? So what is C represents the energy actually for a unit rise. Okay.
Yes, sir.
So if you give, it will rise. If you extract, it will fall. Okay. So the definition of C is simple. It is the amount of energy required to raise the temperature of any amount of substance by 1 degree Celsius. Now, for a limited dimension of substance or limited amount, we can have the heat capacity as a well-known value. But if you go to some ocean, river, even pond also, or desert, Can we measure the heat capacity of the entire ocean? Because we cannot create the energy to raise the temperature of the entire ocean by 1 degree on an average. So heat capacity is the useless thing. Like we cannot find the heat capacity of the entire Thar desert, okay, or run of Kutch. We cannot do such things, right?
Hmm.
So what you do? You go to such places like Thar desert or run of Kutch or Sahara desert, okay, and you take 1 kilogram of that, substance, 1 kg of water from the ocean, 1 kg of sand from the desert, 1 kg of salt from the run of Kutch, correct? And then you heat that 1 kg separately. And then you find the amount again required to raise the temperature of such 1 unit amount of substance by 1 degree, because that is practically feasible. So when you measure the heat capacity for unit mass, the name will change to specific heat capacity. So the word is specific whenever mentioned as a prefix, it always means something defined per unit mass. That's the meaning. So if I read specific heat capacity, you can break into specific and heat capacity. Now heat capacity, you know the definition, but the moment you use the word is specific, you mean do the same experiment but for 1 kg of mass. The limit is well defined. In the word heat capacity, the limit, the amount is not known to you. Clear?
Yes, sir.
But in a specific heat capacity, it is clearly known to you, right? So the idea is simple. The next obvious definition that we should know is going to be
Molar heat.
no, specific heat capacity.
अच्छा.
In gas, 1 kg is not a convenient unit. And that is why we define for 1 mole instead of 1 kg. And therefore, you have to again change the prefix. So instead of specific, use the word molar. Okay. So specific particularly mean per unit mass. And it is not just this chapter. The word is specific whenever applied as a prefix in any definition or any terminology, it always means per unit mass. And it has nothing to do with the chapter thermodynamics. Okay. Any chapter of physics, chemistry, history, civics, geography, whatever. The word is specific always refers to unit mass definition meant for unit mass. So now you can define on your own. The symbol which we use is for small c or s. I will be using s because the small c, capital C may be confusing in many cases. In print, they can use small c, capital C clearly, but in manual writing, I will prefer s. Okay, clear na?
Yes, sir. Yes, sir. Yes.
So the definition is again very common, amount of heat required to raise the temperature of unit mass of substance by 1 degree or 1 Kelvin, more specifically from 14.5 degrees Celsius to Now this is
Why
interesting.
this?
Yeah, why this? So there are many liquids which which is having the anomalous behavior at a very low temperature, close to 0 degree. So in a standard practice, this temperature is chosen as a range in which the properties are not anomalous. Okay, it is kind of fixed property. Okay, like water, will have the anomalous expansion near 4 degrees Celsius. Okay, so water first contract up to 4 and then expand. So the behavior is, you can say, dual behavior around 4 degrees Celsius. So maybe they might have came across many such liquids having similar issues. Okay, so they thought of, okay, taking a range which is free from this anomalous behavior, and that might be the reason this was chosen that time. Exact reason I think we can Google. I never Googled, so you can Google and let me know if you get something more concrete story. Just like the Kelvin story.
Yes.
So there is nothing like Kelvin. It's a river. So similar story must be there. Many times I thought of finding, but I ignored. Okay. Now it's your job to find the story and let me know the story. Okay.
Yes.
Now, even in examination, you should know this range, and you must mention this range to get full marks in school examination. In JEE mains also, this range is used as a assertion reason question. You will come across this range. So whenever we define the specific heat capacity, we prefer this range mostly. Okay. So the definition itself is very simple. We can define as Q upon delta T we have defined earlier, heat capacity. Now, when you define per unit mass, it is becoming mole specific heat capacity. In differential form, we use in physics generally. So you also get used to this way of writing. Okay. So let's say at any instant the mass of the body is m, and you're trying to raise the temperature by dt. So the amount of dq is called the s, right? And from here you get the unit joule per kilogram degree Celsius or joule per kilogram Kelvin. And a similar thing I can say, the S in Fahrenheit is going to be less than S in, right? So raising temperature of something by 1 Fahrenheit is always requiring less energy compared to other cases, right? Other unit like a degree Celsius and
Yes, sir.
Kelvin. I think this we have discussed in temperature scale, right?
Hmm. Yes, sir.
Now the sometimes the specific heat capacity could be function of temperature itself. So you need to use the differential form to integrate and get the answer. Clear? So if S is given as a, and
Yes, sir.
S is actually function of temperature. So I should mention S depends on, I will mention note. So S depends on physical property and temperature of substance. Okay. So you should be aware of the dependency. This is the definition number 2. The third definition which we should know is so what is latent?
So the heat absorbed while at constant temperature while changing the phase.
Hmm. So the reason behind this clandestine, I think there is a word clandestine, hidden, hidden. Hmm.
Done something secretly.
Hmm. But here you're giving energy to something, and as per the earlier perception that whenever energy is given, it should have a direct consequence of change of temperature. This is what we assumed in the beginning, that if I am giving energy to something, its temperature must change, right? But what we realized that during the change of phase, even though we are giving energy, temperature remains constant. So the obvious question was like, where this energy is going actually? Why it is not being able to change the temperature? And now this is the biggest question, which we got the answer finally in kinetic theory of gases. The KTG gave the explanation actually. Now we need to realize that temperature and energy are not directly connected. So
तो
if I
KTG is meant for gases, तो gases to liquid की कैसे बात की
no no
KTG
no
में?
KTG, although it is called for gases, but the idea of KTG is true for all form of substance,
That is
solid also,
अच्छा.
liquid also, gas also. In fact, KTG idea is applied for the photons also. It is applied for the radiation also. It is applied for the electrons also within the conductor. So there are many ideas which we apply.
Right.
Now the idea is, if energy, when we talk about energy, then we need to talk about the form within the body. Okay. So there are two types of energy which we particularly talk in case of substance. One is the real substance, or you can say real gases or liquids. They do interact with each other, unlike the ideal gas which never interact. This is the postulate of KTG, which you will study in KTG. And whenever there is a real interaction, there is a bond or there is a any sort of electromagnetic force of interaction, we define something called potential energy. Now, what is surprising to know that potential energy do not contribute in temperature. So the word temperature actually only signifies one form of energy, and that is the kinetic energy of vibrating or moving molecules or atoms. If we talk about the crystals, it is the vibration, which is again kinetic energy. If you talk about the liquids, it is the vibration and the localized movement, you can say. And if it is gas, then again it's a movement of free particles, free molecules, or air molecules, or whatever gas molecules. So it is the kinetic energy which we perceive as temperature, not the energy. So in any process where energy actually is compensated for the change of potential, you will not see change of temperature. Getting it? So for example, imagine you got a lottery, okay, and after lottery you got a lump sum of 1 CR, 1 crore, and you put that amount into the bank account in mutual fund investment, and then you live the same life as before. then the world will not come to know that you have become rich actually. So the show off is not there, right?
Hmm.
It is completely saved and stored. So this energy called potential. You got a lottery, next day you buy, bought a bike or car and then flaunting the jewelry, going and throwing party to your friends. People will come to know you have now high temperature because that is going for the change of your show of energy. So we say kinetic as show off and potential as hidden. And latent heat talks about the potential energy part. So when heat energy is consumed in changing the configuration, we fail to see the visual effect. In a way, you can say the show off is missing. And therefore, we end up saying that there is no change of temperature because temperature is totally show off.
Hmm.
So we need to understand that a change of temperature requires change of kinetic energy, part of the energy of a system. When a system undergoes change of energy, but not change in the kinetic energy, you will not see the change of temperature. Okay. So we say that when we say the word latent heat, then this energy is totally consumed in reorganizing the molecular arrangement of substance. When I say reorganizing means you change the separation maybe, and change of separation is leading to eventually change of phase actually, right? Because we know that the solid, liquid, gas, they differ in what? Separation, right? So now we have a substance called super light solid, which is lighter than air. But it is called solid because their molecules are still bonded together at a separation bigger than the separation of air molecules. Imagine. So with such an extreme power of attraction, they bond together at a distance more than the air separation. And so they are lighter than air, but they are solid. Okay, he's searching. You got the super light solid?
Aerogel.
Aerogel. Aerogel is, I think, super light. What is the density? Check. Is it less than 1 kg per meter cube? Or,
0.0011 gram per centimeter cube.
so convert this into kilogram.
1.1. 1.1.
Yeah, so close to air actually.
Huh.
Air is 1 actually. It is more than 1 then. Okay, so we have been able to achieve something close to air as a solid. Okay. But in general, okay, let's not talk about this research. In general, the phase actually defines the separation, but not just separation. It defines some sort of interaction. Okay. So when you say change of phase, you actually talk about the change of interaction, separation actually. I mean, they separate and they interact differently. The force of interaction may decrease from the solid to liquid and further to gas. Okay. Now, when you're giving energy, and if molecules are attractive in nature, if they are attracting each other, putting them away is against their nature, right? Because they are attracting. Imagine that two magnets, one is north and south pole, they are pulling towards each other themselves naturally, and you're trying to make them apart. Does this require energy? It requires, no? Can you do it without applying a force? They are attracting, you're trying to pull them apart. So one is north, other is south, and if you want to pull them apart, you have to do some work, right?
Huh. Huh.
Now, One way is you can, you can actually give energy by doing work. But in case of substance, you cannot hold the molecule and pull them apart, right? You can't, hold them physically. So when this job is done by a heat process, then heat is received by the molecules and they migrate away from each other. But while doing so, they increase their potential because under the attractive force, when you go away, your potential will grow actually. So we have talked about the potential, right? Anything against the nature will increase the potential, and as per nature will decrease the potential. So when attractive molecules, which by nature attract each other, when they are put at a larger separation, their potential will grow.
Hmm.
So when solid becomes liquid, you are growing the separation, right? Generally. And by doing so, you're trying to increase the potential energy, right? And that is why we need to give energy to change the phase, right?
Yes, sir.
This energy is the latent heat. The latent heat is the energy required to change the configuration. So when, let's say, there are some gases uh, which are cooled down naturally by letting them expand abruptly. So when gas expand abruptly, the potential grows at the expense of loss of kinetic, which in turn result into the loss of temperature. And they cool by expansion. Getting it? This is called adiabatic cooling. You expand abruptly, and how you achieve this? So you have the two compartments in which one is almost empty, like highly vacuum part. Other is filled with gas, and there is a hole, tiny
Hmm.
hole, and the hole is not very small, big enough. When the gas will enter the other compartment, it will expand suddenly,
Right, sir.
which in turn will increase the potential and decrease the temperature.
Decrease the temperature. Right, sir.
We achieve the cooling effect actually.
Adiabatic condition है ना सर ये?
Ah. So, but this is for adiabatic condition for real gases, not for ideal gases. In ideal gas, what happens? Temperature remains constant.
Adiabatic में?
हाँ, तो यहाँ पे क्या हो रहा है? There is no work done ना. In a free expansion, there is no work.
अच्छा हाँ.
ऊपर हो गया यहाँ पे. So anyway, latent heat is something which we need to really understand. It is not something just formula. It is the energy which consumed in changing the configuration, which in turn changes the potential. And because the kinetic part of energy is not been affected, so the temperature, ये पूरी कहानी.
हम्म.
आपने पोटेंशियल बदला, काइनेटिक नहीं बदला, तो आपने शो ऑफ नहीं किया, आपने सब कुछ छिपा लिया. यो बैंक अकाउंट जो है वो थोड़ा सा रिच हो गया, बट ये दुनिया को नहीं मालूम चला, एक्सेप्ट द गवर्नमेंट ऑफ इंडिया.
Time corner.
हाँ बस, पैन कार्ड से मिल जाएगा ना तो,
Right, sir.
और टैक्स तो पे करना ही पड़ेगा.
Not necessary.
ओके चलो, टैक्स पे करना जरूरी है ना, नहीं तो हमारे नेता अमीर कैसे बनेंगे, यानी कि बेचारे गरीब रहेंगे. तो इट इज द okay now, latent heat is the energy. So if I define the latent heat, it is heat energy which is used for changing the configuration of substance, thus changing
Potential energy.
potential energy without affecting its kinetic energy. Okay. Hence, its temperature is only a function of K. ठीक है.
Yes, sir.
Temperature has nothing to do with the potential part. It has to do with the kinetic part. ठीक है. तो ये तो बात होगी लेटेंट हीट की. हमें बात करना है किसका? हमें बात करना है स्पेसिफिक लेटेंट हीट का, है ना. क्योंकि फॉर्मूला तो उसके लिए होता है. अच्छा, पूरी किताबों में क्या होगा, in books they don't use the word specific latent heat capacity, they only called it latent heat capacity, and it is kind of understood. So let me define the specific clear.
Yes, sir.
So it is simply defined as L equals to Q by M. फिर चेंज करना है. यानी कि L इज द एनर्जी रिक्वायर्ड टू चेंज द फेज ऑफ यूनिट मास. यानी 1 kg के लिए L चाहिए, 2 kg के लिए 2L चाहिए, 3 kg के लिए 3L चाहिए, 4 kg के लिए 4L चाहिए, M kg के लिए ML चाहिए बस. ठीक है.
Yes, sir.
इसमें बेसिक चीज जान लो थोड़े से. अब देखो यहाँ पे किसी को मेल्ट करना हो तो दे दो पैसे, और फ्रीज करना तो निकालो पैसे. जनरली हम इसे लेटेंट और फ्यूजन कहते हैं. फ्यूजन और मेल्टिंग इसको ऐसे कहते हैं. तो इसमें क्या बोलेंगे कि अमाउंट ऑफ एनर्जी रिक्वायर्ड टू चेंज द फेज ऑफ सब्सटेंस फ्रॉम सॉलिड टू लिक्विड, और वाइस वर्सा दोनों होता है. बस
Hmm.
डिफरेंस का एक में देना होता है, एक में निकालना होता है. ठीक है। अब
यस सर।
फ्यूजन या वेपोराइजेशन की कुछ खास बातें हम बातें हैं उस पर थोड़ी देर में।
सब्लिमेशन भी होती है ना सर?
हाँ,
इवापोरेशन, लिक्विफैक्शन।
अच्छा, ये दोनों के लिए ट्रू होता है, चाहे इवेपोरेशन की बात करें या
वेपराइज।
वेपोराइजेशन की बात करें। तो वेपोराइजेशन जनरली हम बात करते हैं बॉइलिंग के केस में, और इवेपोरेशन बात करते हैं हम लोग इन जनरल किसी भी टेम्परेचर पे होता है। तो बॉइलिंग में खास बात क्या है कि इट हैपेंस ओनली एट वन पर्टिकुलर टेम्परेचर अंडर एक्सटर्नल जो भी हमारा प्रेशर और
180
हाँ जो भी है कंडीशन। और लास्ट होता है हमारा, तो यहाँ पे क्या होता है, इसमें होता है हमारा सौ, ऐसे लिख देता हूँ, रिएक्शन देता हूँ।
सॉलिड लिक्विड।
बट ये होता है एट एमपी, एमपी मतलब मेल्टिंग पॉइंट।
अच्छा।
मतलब ये नहीं कि किसी भी टेम्परेचर पर हो जाएगा, ये मेल्टिंग पॉइंट पे ही होगा ये।
हम्म।
बट मेल्टिंग पॉइंट को हम एक्सटर्नली कंट्रोल कर सकते हैं।
प्रेशर से।
हाँ, जैसे कि एट हाई प्रेशर मेल्टिंग पॉइंट लोअर्स।
राइट सर।
तो इसका जो होता है, जैसे आइस आइस स्केटिंग में यूज करते हैं। जैसे आइस स्केटिंग में क्या होता है, जो स्केटिंग तुम्हारा जिस पे तुम खड़े हो, उसके नीचे का जो आइस है वो हाई प्रेशर पे है तुम्हारे वेट की वजह से। तो वो आइस उसी टेम्परेचर पे लिक्विफाई होता है, मतलब कि -10 डिग्री है। अब -10 पे जनरली आइस आइस रहता है, 0 पे होता है ना। बट
हाँ।
हमारे वेट के प्रेशर से उसका जो मेल्टिंग पॉइंट है वो -15 हो जाएगा। तो -10 पे मेल्ट हो जाएगा वो, एंड दैट विल एक्ट एज
हाँ।
ए लुब्रिकेंट, और तुम आराम से फिसल लोगे। और जैसे ही आगे बढ़ोगे फिर से फ्रीज हो जाएगा वो, क्योंकि प्रेशर घट गया ना, फिर से एटमॉस्फेरिक प्रेशर हो गया।
राइट सर।
इस तरह से काम करता है लुब्रिकेंट का, यानी कि आइस स्केटिंग में हम हाई प्रेशर से मेल्ट कर लेते हैं और उसको जो है लुब्रिकेंट बना यूज करते हैं। समझे?
इवन एक आइस के ब्लॉक के ऊपर वायर रखते हैं सर, तो वायर
हाँ हाँ,
पास हो जाता है ऊपर से।
एग्जैक्टली। तो वो पार्ट मेल्ट होते चला जाता है, उसको बोलते हैं।
नीचे मेल्ट होता है, ऊपर फ्रीज होता जाता है।
हाँ, उसको बोलते हैं रेनेगेशन, होता है, उसको बोलते हैं रेनेगेशन।
हाँ।
रेनेगेशन या रेलिगेशन, मुझे कंफ्यूजन होता है, रेनेगेशन
मुझे भी नाम याद नहीं है सर।
और रेलिगेशन, आई थिंक एक रेलिगेशन।
रेलेगेशन होगा सर, आई थिंक।
कौन सा, पहला है या दूसरा वाला?
सेकंड वाला आई थिंक। सेकंड वाला है
हाँ,
सर। रेजिलेशन।
रेजी।
हाँ, REGLATION।
अच्छा हाँ, रेजिलेशन, भाई अजीब सा नाम।
रेजिलेशन।
रेगुलेशन, रेगुलेशन, दोनों गलत। सारी।
वही ना सर, वो रेजिलेशन रेगुलेशन सेम थिंग।
हाँ ठीक है, हाँ तुमने सही बोला।
हाँ।
अभी ये मुझे ये वर्ड लिख लेता हूँ ताकि याद रहे। खुद याद नहीं रहता मुझे, कुछ याद नहीं रहता रहेगा। हम्म। तो ये बहुत ही फेमस एक्सपेरिमेंट है। और इसी मेथड से तो तुम आराम से आइस को कट कर लो, यानी कि आइस के थ्रू एवरीथिंग इन पास अंडर प्रेशर, एंड फिर उसको फ्रीज भी हो जाएगा। एनीवे, थर्ड है हमारा एल एस
latent of sublimation.
सॉलिड टू
Gas.
वेपर, ठीक है। इसमें तो लिखा ही नहीं, लिक्विड टू।
Vapor.
तो व्हाट इज द डिफरेंस बिटवीन गैस एंड वेपर? बताओ क्या डिफरेंस है।
पता नहीं सर।
देखो, gas cannot be liquefied, only vapor can be liquefied, and it only happens at below, or you can say below,
Critical temperature.
there is something called critical temperature. So only if you reach below critical temperature, by increasing pressure you can convert a gas into liquid. So when you reach that condition, we prefer to call vapor. So vapor can change the phase, not the gas, ठीक है।
Yes sir.
अब कुछ और बातें बता देता हूँ, जैसे कि हाँ, ए लिक्विड लिखा हमने, इन डिफरेंशियल फॉर्म लिख दो। हम्म, तो यहाँ पे कुछ पॉइंट केमिस्ट्री से लिख के याद करना चाहिए कि मेल्टिंग पॉइंट विल लोअर एट हाई प्रेशर, राइट। सो विद द इंक्रीज ऑफ प्रेशर मेल्टिंग पॉइंट लोअर, राइट, which means melting will occur at lower pressure, lower temperature देन एक्चुअल। अब मान लो कि पहले अगर 0 पे था तो वो -5 पे ही मेल्ट हो जाएगा अगर प्रेशर बढ़ा दो, ठीक है। नहीं ठीक है, ठीक है। अब ये मुझे बताओ कि एल वी वर्सेस एल एफ, दोनों में किसकी वैल्यू ज्यादा होनी चाहिए और क्यों?
तो आई थिंक फ्यूजन की ज्यादा होनी चाहिए।
फ्यूजन में तो इंटर मोलिकुलर सेपरेशन कम ही बढ़ता है ना।
अच्छा नहीं, वेपराइजेशन क्यों? बिकॉज फ्यूजन में ऑलरेडी वो रिपल्सिव फोर्सेस लग रहे हैं। तो सॉलिड को आप कंप्रेस करके ही रख रहे हो तो।
ये सॉलिड से लिक्विड जाने में इंटर मोलिकुलर सेपरेशन कितना ही बढ़ता है, कम ही बढ़ता है ना।
हाँ।
पानी का
अच्छा, गैसेस वी हैव टू टेक ऑलमोस्ट इनफाइनाइट।
हाँ, ऐसे सोचो ना कि भाई, अ, पानी का डेंसिटी है 1000, आयरन का डेंसिटी कितना है 7800,
राइट सर।
तब 8 गुना ही तो ज्यादा है, ज्यादा थोड़ी हुआ। लेकिन अब पानी का डेंसिटी 1000 है, हवा का 1 है, 1000 गुना बढ़ गया ना।
हम्म।
ऐसे समझ लो, मतलब एक आइडिया के लिए कि जो सेपरेशन है वो लिक्विड वेपर में बहुत ज्यादा ड्रेस्टिकली बढ़ रहा है ना।
राइट सर।
तो वहां पे हमें पोटेंशियल एनर्जी जो देना पड़ेगा वो बहुत ज्यादा डिमांड है वहां पे, इसलिए एल एफ छोटा होता है, एल भी बहुत बड़ा होता है। और इसलिए याद रखना चाहिए कि फॉर वाटर टू वाटर वेपर, एल वी का वैल्यू होता है कितना, 540 कैलोरी फॉर 1 ग्राम ओनली। और ये होता है थियोरेटिकल आंसर, थियोरेटिकल,
हम्म।
प्रैक्टिकली कम होता है। ठीक है। और LF तो ओनली 80 कैलोरी पर ग्राम। मतलब मुझे अगर 1 ग्राम आइस को मेल्ट करके बनाना है पानी एट 0 डिग्री, तो मुझे 80 कैलोरी में काम चल जाएगा। मुझे अगर 100 ग्राम आइस को मेल्ट करना है तो मुझे 100 × 80 कर देने की 8000 कैलोरी में काम हो गया। लेकिन 100 ग्राम अगर हमें चाहिए स्टीम बनाना है पानी से एट 100, तो 54,000 कैलोरी चाहिए। बहुत ज़्यादा हो गया ना।
हम्म।
रफली 7 टाइम्स। 54,000 और इधर 8,000 है ना। इसलिए जनरली वेपराइजेशन इज मोर डिफिकल्ट, डिमांड्स मोर एनर्जी। अब वेपराइजेशन बहुत जरूरी है देश की तरक्की के लिए, क्या है कि नहीं।
क्या सर?
बोलो, वेपराइजेशन बहुत जरूरी है देश की तरक्की के लिए ना।
ये क्यों?
अरे तभी तो देश की तरक्की होती है। देश की तरक्की के लिए चाहिए करंट, इलेक्ट्रिसिटी कहाँ से मिलेगा।
अच्छा, थर्मल पावर।
पावर जनरेट करते हैं।
हाँ।
मैक्सिमम जो न्यूक्लियर पावर हो, चाहे थर्मल पावर हो, चाहे कोल से यूज करें, द होल पर्पस इज टू रन द टरबाइन, एंड टू रन द टरबाइन वी यूज वेपर। तो ठीक है, इसी आइडिया पे बहुत सारे आई थिंक क्रूज भी चलते हैं।
हम्म।
होता है, बहुत कुछ होता है इस पे। और जेम्स वोट ने तो बनाया था स्टीम इंजन इसी पे।
हाँ।
तो अच्छी बात है। ठीक है, तो बाकी थोड़ी बहुत बातें बातें बच गई हैं, तो हम लोग क्लास में निपटा देंगे इसको। ठीक है,
यस
चलो अभी आराम करो।
सर। बाय सर। थैंक यू सर।
राइट।